right, let's begin with lesson 2. We're going to recap the development of the co-height function to go along with the height function that we developed in the last lesson. We opened by revisiting our Ferris wheel here, looking at one that has a radius of 50 feet. Instead of measuring the height from the bottom of the page as we did in our model, which represented the ground, we decided to measure our height with respect to the horizontal line through the center of the wheel. So we were measuring height with respect to this line here, treating the center of the wheel as a kind of origin for measurements on our Ferris wheel. Once again, we started in the 3 o'clock position, so this right here is our start point, and our height is measured relative to this line here. So your task was to mark the diagram to show the position of a passenger car at 30-degree intervals as it rotates counterclockwise around the Ferris wheel. Then we were asked to sketch the graph of the height function of the passenger car for one turn of the wheel. So this was a quick version of what we developed in the first lesson, but this time measuring from the center of the wheel. When you marked your circle, your Ferris wheel, you would get your intervals as shown here. And then you could just draw straight lines across to approximate the height at each of these intervals. Many students noticed that 120 degrees would be the same as 60, 150 the same as 30, 360 the same as 180, and so on as we move down the wheel, with 210 lining up to 330 and 240 lining up to 300, and that this allowed them to make their height measurements a little bit more quickly than measuring each one individually. So we made the graph that looked like this, and we were asked to identify the radius of the wheel from the graph. Students noticed that the maximum height here matches up with the radius, and that the minimum height matches up with the opposite of the radius. So we could see the radius here at our maximum value, and we could also find it by considering the opposite of our minimum value. And we were asked, if the center of the wheel is 55 feet above the ground, how high is the passenger car above the ground at the top of the wheel? Well, the passenger car would be 50 feet from the center, another 50 feet down, that's 100 feet. And if the center was 55 feet, then there was another 5 feet there, and the passenger car would be 105 feet above the ground at that height. So in this exercise, we changed what we measured from to the horizontal line at the center of the wheel, and we called this vertical displacement. You might remember from science classes that displacement has a sign. It can be positive or negative, as opposed to distance that does not have a sign. It's an absolute value. So then we asked, is there another measurement that we could model as a function of degrees rotated counterclockwise from the car's starting position? Students thought about this for a while. They sent out some ideas. Maybe they could measure time, but ultimately we came to the conclusion that what you could also measure was horizontal displacement. The distance left and right from the center of the wheel. So that's our horizontal displacement. We decided to call our horizontal displacement co-height because it is related to the height. We considered how we can assign positive and negative values to co-height. And we concluded that as you rotate from 90 degrees to 270 degrees, that area would be negative. And as you rotated from 270 up to 0 and from 0 to 90, that area would be positive because that gives us our negative numbers going off to the left and our positive numbers off to the right, as we're accustomed to in our coordinate planes. So if we look at our radius here, we have a height function and a co-height function. The starting value of our co-height here is going to be 50 feet from the center of the circle or the Ferris wheel. So it's 50 feet from the center of the Ferris wheel. Next, we considered if the passenger car had rotated 90 degrees counterclockwise from its initial position of the 3 o'clock wheel, and asked what the co-height of the car was in this position. So if we're up here, then our horizontal distance is 0 feet. Then we asked if there were a maximum value and a minimum value for the co-height of the passenger car. So the maximum value occurs over here. That's as far as it goes to the right. So the maximum value is 50 feet, and the minimum value occurs over here as far as it could go to the left, and that is negative 50 feet. We'll conclude this section of our recap here and put our activity using our paper model into the next video.